a direct current circuit, voltage drop happens because of the wire's resistance. This resistance hinders the flow of electrons. As these electrons move through the wire, the voltage decreases. To determine voltage drop in a direct current circuit, we use a straightforward formula: volts equals amps times ohms, where volts is the voltage drop, measured in volts, amps is the current flowing through the wire, measured in amps, and ohms is the resistance of the wire, measured in ohms. Now consider a scenario where no load, is connected to the end of the wire. In this case, current doesn't flow through the wire, and as a result, there's no voltage drop. The absence of current means the wire's resistance has no effect. On the other hand, when a load is connected to the wire's end, current begins to flow. The wire's resistance interferes with the electron flow, leading to a voltage drop between the wire's beginning and end. This is where the formula becomes useful in calculating that voltage drop. To calculate the voltage drop, you need firstly the resistance of the wire per 1000 feet, which can be found in a wire table. Secondly, the total length of the wire. Once you have these two values, we can calculate the voltage drop. The formula is volts equals resistance per 1000 feet times total length over 1000 times current. In summary, voltage drop is a direct current circuit is caused by the resistance of the wire. Without a load, there is no current and consequently no voltage drop. However, with a load, current flows and the wire's resistance creates a voltage drop. Let's delve deeper into the factors influencing voltage drop in direct current circuits. Firstly, resistance of the wire. Different materials have different resistivities. Copper and aluminum are commonly used in electrical wiring because they have relatively low resistance. However, even these materials offer some resistance to current flow. The longer the wire, the greater the resistance. A longer path means electrons have to navigate more of the material, encountering more obstacles along the way. The cross-sectional area of the wire also plays a crucial role. A thicker wire, with a larger cross-sectional area, provides more space for electrons to flow, reducing resistance. Wire gauge is a standard measure of wire thickness. Lower gauge numbers indicate thicker wires. For example, a 10 gauge wire is thicker than a 14 gauge wire. Now, let's consider current. The amount of current flowing through the wire directly affects the voltage drop. High current means more electrons are moving through the wire, leading to a greater voltage drop due to the resistance. This relationship is described by Ohm's law: volts equals amps times ohms. In a practical application, voltage drop is a critical consideration for electrical systems. Excessive voltage drop can cause lights to dim, motors to run inefficiently, and electronic devices to malfunction. Therefore, it's important to select the correct wire size for a given application to minimize voltage drop and ensure proper operation of electrical equipment. To better understand voltage drop, let's consider a few examples. Imagine a long extension cord powering a work light. If the extension cord is too thin or too long, you might notice the light is dimmer than usual. This is because the voltage reaching the light has dropped due to the resistance of the extension cord. Now, consider a high-power amplifier drawing a significant amount of current. If the power supply wires are not thick enough, the voltage at the amplifier may drop, causing it to distort or malfunction. In industrial settings, voltage drop can be a major concern. Long cable runs to motors, sensors, and other equipment can experience significant voltage drop, affecting their performance. To mitigate voltage drop, engineers carefully calculate the required wire size based on the load current, cable length, and allowable voltage drop percentage. There are several methods to reduce voltage drop in electrical circuits. Firstly, using thicker wires. Increasing the wire gauge reduces resistance, allowing more current to flow with less voltage drop. Secondly, shortening the wire length. Shorter wire runs naturally have less resistance, minimizing voltage drop. Thirdly, increasing the voltage. Higher voltage systems can deliver the same amount of power with low current, reducing voltage drop. However, this approach may require different types of equipment and safety precautions. Fourthly, using multiple parallel conductors. Splitting the current across multiple conductors reduces the current in each conductor, lowering voltage drop. This technique is commonly used in high current applications. Now let's focus on calculating voltage drop in more detail. The basic formula volts equals amps times ohms is the foundation. However, in real-world scenarios, we need to consider additional factors. The resistance of the wire is typically provided in ohms per foot or ohms per 1,000 feet in wire tables. These tables list the resistance values for different wire gauges and materials. To calculate the total resistance of a wire run, you multiply the resistance per unit length by the total length of the wire. Remember to account for both the positive and negative conductors in a two-wire circuit, as both contribute to the overall resistance. Temperature also affects the resistance of the wire. As the temperature increases, the resistance of most conductors also increases. This effect is more pronounced in some materials than others. Wire tables typically provide resistance values at a specific temperature, usually 20 degrees Celsius. For accurate voltage drop calculations, especially in high-temperature environments, you may need to adjust the resistance value accordingly. In alternating current circuits, voltage drop calculations are more complex due to the presence of inductance and capacitance. These reactive components introduce impedance, which is the AC equivalent of resistance. Impedance is a combination of resistance and reactance. Voltage drop in alternating current circuits is calculated using a vector sum of the resistive and reactive voltage drops. This requires knowledge of the phase angle between the current and voltage. Now let's consider some common misconceptions about voltage drop. One misconception is that voltage drop is always a problem. In some cases, a small amount of voltage drop is acceptable and even desirable. For example, in a current-limiting resistor, voltage drop is intentionally used to reduce the voltage applied to a sensitive component. Another misconception is that voltage drop only affects the load. Voltage drop affects the entire circuit, reducing the voltage available to all components downstream. Finally, some people believe that voltage drop is only a concern in long wire runs. While long wire runs are more susceptible to voltage drop, even short wire runs can experience significant voltage drop if the wire gauge is too small or the current is too high. Voltage drop calculations are an essential part of electrical design. Electrical engineers use these calculations to ensure that electrical systems operate safely and efficiently. Accurate voltage drop calculations help to prevent equipment malfunctions, reduce energy waste, and improve overall system performance. There are several software tools and online calculators available to simplify voltage drop calculations. These tools typically require inputs such as wire gauge, wire material, wire length, current, and voltage. The software then calculates the voltage drop and provides recommendations for wire size adjustments. Understanding voltage drop is not just for engineers. Electricians, technicians, and even homeowners can benefit from this knowledge. Knowing how to calculate and mitigate voltage drop can help to troubleshoot electrical problems, improve the performance of electrical equipment, and ensure electrical safety. So to recap, voltage drop is a fundamental concept in electrical engineering. It's caused by the resistance of the wire, affected by current, length, and wire gauge. Proper understanding and calculation of voltage drop are essential for designing and maintaining efficient and reliable electrical systems. Always consult with qualified professionals for electrical work and follow local electrical codes and regulations. These codes and regulations specify the maximum allowable voltage drop for various applications. Exceeding these limits can be a safety hazard and may violate electrical codes. Voltage drop considerations also extend to grounding conductors. Grounding conductors provide a path for fault current to flow back to the source, protecting people from electrical shock. Adequate sizing of grounding conductors is crucial to minimize voltage drop during a fault condition, ensuring that protective devices operate quickly and effectively. In conclusion, understanding voltage drop is crucial for anyone working with electrical circuits. From selecting the right wire gauge to troubleshooting electrical problems, a solid grasp of voltage drop principles can save time, money, and even lives. Therefore, it's encouraged to continue learning about electrical concepts and staying up to date on the latest electrical codes and best practices. There are plenty of resources available online, in libraries, and through professional organizations. These resources can help you deepen your knowledge and improve your skills in the field of electricity. Remember, electricity is a powerful force that must be treated with respect. Always follow safety precautions and seek guidance from qualified professionals when working with electrical systems. Now, consider how voltage drop impacts different types of loads. Resistive loads, such as incandescent light bulbs and heaters, are directly affected by voltage drop. A lower voltage results in reduced power output, causing the light to dim or the heater to produce less heat. Inductive loads, such as motors and transformers, are also sensitive to voltage drop. A reduced voltage can cause motors to run slower and less efficiently, potentially leading to overheating and damage. Electronic devices, such as computers and televisions, are designed to operate within a specific voltage range. Excessive voltage drop can cause these devices to malfunction or shut down completely. In sensitive electronic equipment, voltage regulators are often used to maintain a stable voltage despite fluctuations in the supply voltage. Voltage regulators compensate for voltage drop by adjusting the current flow to maintain a constant output voltage. These devices are commonly used in power supplies, battery chargers, and other electronic circuits. Another important aspect of voltage drop is its impact on energy efficiency. Excessive voltage drop wastes energy in the form of heat. The energy lost due to voltage drop is proportional to the square of the current. Therefore, reducing voltage drop not only improves the performance of electrical equipment, but also reduces energy consumption and lowers operating costs. In large industrial facilities, voltage drop can have a significant impact on overall energy efficiency. Optimizing wire sizes and reducing cable lengths can save thousands of dollars in energy costs each year. These energy savings can also contribute to environmental sustainability by reducing carbon emissions. Voltage drop is also an important consideration in renewable energy systems such as solar and wind power installations. Long cable runs from solar panels or wind turbines to the main electrical panel can experience significant voltage drop. Careful planning and selection of appropriate wire sizes are essential to maximize energy production and minimize losses in these systems. In addition to wire size and cable length, the type of cable used can also affect voltage drop. Different cable constructions have different resistance values. For example, single conductor cables typically have lower resistance than multi-conductor cables. Shielded cables can also have higher resistance due to the added layers of insulation and shielding. The National Electrical Code, or NEC, provides guidelines for calculating voltage drop and selecting appropriate wire sizes. NEC Section 210.19 A1 requires that branch circuit conductors be sized to prevent a voltage drop of more than 3% at the furthest outlet. NEC Section 215.2 A1 requires that feeder conductors be sized to prevent a voltage drop of more than 3% to the furthest outlet served. These voltage drop limits are intended to ensure that electrical equipment operates safely and efficiently. The NEC also provides tables and formulas for calculating voltage drop in different types of circuits. These resources can be helpful for electrical designers and installers to comply with NEC requirements. Understanding voltage drop is also important for troubleshooting electrical problems. Unusual voltage readings at an outlet or piece of equipment can indicate excessive voltage drop. This could be caused by undersized wires, loose connections, or damaged cables. By measuring the voltage at different points in the circuit, you can pinpoint the source of the voltage drop and take corrective action. In conclusion, voltage drop is a critical concept in electrical engineering that affects the performance, efficiency, and safety of electrical systems. Understanding the causes of voltage drop, how to calculate it, and how to mitigate it is essential for anyone working with electricity. By following best practices and complying with electrical codes, you can ensure that electrical systems operate reliably and efficiently. Also, When you are performing voltage drop calculations, make sure to use the correct formulas and values for the specific type of circuit you are working with. Different types of circuits, such as direct current and alternating current circuits, require different voltage drop calculations. Make sure to consult with qualified professionals and refer to electrical codes and standards for guidance. Also, remember that voltage drop is not just a theoretical concept. It has real-world implications that can affect the operation of electrical equipment. By understanding voltage drop, you can ensure that electrical systems operate safely and efficiently.